I am Brian Mulligan, also known as Astrobit. I am missing my partner this week. She unfortunately got called away for an emergency. So Major Merger is not here this month. She'll be back next month, I promise. I hope. It's always so weird when I'm up here doing this by myself. All right, so astronomy in the news for this month. Is this on? There we go. All right. So first up, the night sky is full of a faint, diffuse background infrared light. Brett McGuire, an astrochemist working at the National Radio Astronomy Observatory, used a Green Bank telescope in West Virginia to look at this diffuse glow, and he found radio fingerprints of a molecule called Benzo Nitrile. It's a type of polycyclic aromatic hydrocarbon, which is, for all of you organic chemistry people here, essentially, related to the stuff related to soot, essentially. So pHs are very common in the universe, but they're typically found near very hot and evolved stars. In this case, benzonitrile was found in a cold molecular cloud and was 4 times more abundant than was expected from chemical models of such cold clouds. Further research is being done to remedy the mismatch between observations and theory and to come up with an easier to pronounce name. Next up, an update on Tabbies Star. So a follow-up study of the star that was made famous as the possible site of alien megastructures has concluded that the cause is most likely dust. So boring. The star is known as KIC 8462852, better known as Tabbies Star, after its discoverer Tabitha Boyajian. It was observed to have unusual brightness variations that last for periods of a couple days to a couple months, with no obvious pattern to these variations. Several mechanisms have been proposed, including that an alien intelligence was in the process of building a giant sphere around the star to collect the star's light. A follow-up study was just completed by Tabby's group that looked at the star in different colors of light. The team discovered that the brightness variations are not the same in different colors, meaning that the variations are not due to solid structures. The variations are strongest in blue light and stronger in blue than in red light, which is consistent with what happens with dust. So the same reason the sky's blue, dust tends to scatter blue light more than red light. So yeah, no aliens. Dr. Boyajian and her team raised over $10,000 using Kickstarter to fund this research. It's the first effort to fund research of a specific object using crowdfunding. It's an exciting new avenue for possibly funding basic astronomical research. However, please do not tell our president about this. Don't give him any ideas. There's another star that's been identified with very strange dimming behavior. In this case, however, the discoverers are fairly certain it's caused by orbiting clouds of wrecked planet debris. The star is known as RZ Piscium. It's located about 550 light years away and appears in the constellation Pisces. Observations of this sun-like star have revealed extreme and unpredictable dimming episodes during which the star dims up to 90%. Christine Ponzi, who you see on the lower right here, is a doctoral student at the Rochester Institute of Technology in New York and lead author in the study. She observed massive blobs of gas and dust spiraling around the star and probably falling into it. The star is a young star, but it emits a lot more infrared radiation than visible or ultraviolet light, suggesting that there's a massive amount of gas and dust around the star that absorbs the ultraviolet light and re-emits it as heat. Normally, this material around a star would coalesce and form planets, but the excess of gas and dust suggests that any protoplanets have been destroyed in this particular case. Observations so far have failed to find a nearby Death Star, but instead, the lack of planets is due to the gravitational pull of the host star preventing the material from coalescing into full-size planets. All right, next up, Nora Shipp is a graduate student at the University of Chicago. I saw somebody back there wearing the University of Chicago shirt. I'm assuming it's not Nora. She used data from the Dark Energy Survey to look for streams of stars in our own Milky Way. So the Dark Energy Survey began in 2013. It's similar to HETDEX in that its goal is to map the universe and understand dark energy, but it uses a slightly different method. It covers a large portion of the sky, not as large as HETEX, I don't think. But NORA used the images from this survey to look instead for stars that are within our own Milky Way galaxy. The method that she used found stars that are related to one another and grouped into streams. So you can see a couple of examples here. The dark splotches here are streams of stars that she found in this method. Such streams are the result of smaller galaxies having merged with the Milky Way millions or billions of years ago. The team found 11 never-before identified streams, increasing the number from well, I guess there's about 10 or so that are already identified. They found 11 more. 4 of these new ones are identified with globular clusters, which have never been seen before. Globular clusters have, not the streams. Another interesting aspect of this research was the naming convention used by the authors. So most astronomical units get very, very boring names or identifiers that are used to recognize them and describe them in a particular catalog. In fact, my girlfriend was just complaining to me a couple of weeks ago about how all of our objects have these really horribly boring names. This team chose to name the streams after aquatic terms from geographically distinct cultures of India, Chile, and Australia. So they used names such as Indus, Elqui, Wilka Yaku, and Wambalong. So the method that NORA used in this research is novel and is likely to result in many more such streams being identified in the coming years. All right, and next up, so for the first time, astronomers have imaged giant bubbles on the surface of a red giant star. So here's a direct image of a star. The bright areas and the dark areas are kind of showing the different regions of the surface. The bright areas is essentially the bubbles that they're seeing. The bubbles are convective cells that bring heat from the interior of the star to its surface. Once at the surface, the bubbles release radiation and cool, allowing it to sink back into the interior of the star. You've probably seen something similar when you're boiling a pot of water. The same phenomenon occurs on the sun, but has never been directly observed on another star until now. Claudia Palladini is an astronomer at the European Space Observatory. She led a team that observed Pi 1 Gruis. I'm not very good at pronouncing this one. It's a red giant star located 530 light years away from Earth. The star is in its later stages of life, having run out of hydrogen fuel in the core of the star. This caused the star to swell up to about 350 times the diameter of our sun. The convective cells that you see are about 75 million miles across, or about half the distance between the Earth and the sun. By comparison, the cells on our own sun are only about 1,500 kilometers across, which is basically the distance between Austin and Chicago. The observed size of the structures on this star is consistent with the size predicted from the physics of the structure of stars. And in the future, the team hopes to get observations that show how the cells change and how long each of the individual cells last. And finally, our Astronomy Not in the News. This is a segment that we do covering a story that's generated a lot of discussion within the astronomical community, but hasn't necessarily made the major news media. This month's study comes from Benham Darvish of Caltech. He and his team looked at a sample of over 100,000 galaxies out to about 7 billion light years to understand what causes galaxies to have bursts of star formation or quenching or slowing down of its star formation. Their study found that smaller galaxies are more likely to experience quenching, and more massive galaxies are more likely to experience bursts of star formation. Galaxies that are nearer to the center of their clusters are quenching faster than those that are near the edges, meaning that the more dense material that are around causes the galaxies to slow down their star formation quicker. At greater distances, which also means earlier in the history of the universe, the factors that cause this quenching tended to have a larger effect on the galaxies than occurs during the present period of the universe. This study helps to understand how galaxies evolve and how they come to look the way that we see them today. All right, so that is all I have for Astronomy in the News for January 2018. Thank you all for coming, and enjoy the rest of the show.